Welcome everyone to today's tutorial. We're going to be talking about substitution in logarithm, and for the remaining part of the video, after which I finish talking on substitution in logarithm, I'm going to treat some examples that are still related in logarithms. So when we talk about substitution in logarithm, we're actually talking about some questions or some expressions in logarithm that involves breaking a given function, such function, to its simplest form, and thereafter substituting its actual values for final evaluation. So there are such logarithmic expression that involves you substituting their values to get their final evaluation. I'm going to take us through some examples. First example I have here, example 1. Let's find the log of 40. Now take note, when you do not see the base written explicitly, it actually means that logarithm is in base 10. So each of these logarithms are in base 10, are all in base 10. But most times you just write it like that without showing the base. But that shows that logarithm is the common logarithm, and that's in base 10. But in most cases where you see different bases appear as the logarithm value, then it shows that it's been specified that that's the base that logarithm is. In this case it's 2. That's just by the way. Okay, so back to our example. For us to simplify this expression log 14 base 10, I'm simply going to break this expression down, and I'm doing that by breaking 40. I'm going to figure out the numbers of that are factors of 40, that when I multiply them I'll get 40, and those numbers are 8 times 5. 8 times 5 is 40. So I will keep on breaking them until I have expressions that are included here in my work. So I'm going to open my brackets by using this log in base 10 to multiply each of these numbers, and when that happens I'll have a plus sign that separates them. This is a rule in logarithm that tells us that the log of two numbers being multiplied, Q and A, or Q and M, when you have the log of two numbers being multiplied, the same thing as the log of the addition of those two numbers, or the logarithms of each of those numbers being added together. Okay, so that's what I have here. So now we notice that I have log 5 here, so I can easily substitute it here. But I don't have log 8. I don't have it in my list here. So the best thing for me, so I'm still going to break down this expression to have a simpler form on it. So I'll have log 10. So what can I do to 8 that can be broken down for me to get an expression here? That's 2 raised to the power of 3 is 8. So I'll replace it with 2 raised to the power of 3 plus log 5 in base 10. And so remember what the law says. A law in logarithm says that the power of a number can be multiplied, can be used to multiply the logarithm. So my 3 as the power of these two will come in front of my logarithm, and the rest still remain the same. So I have this whole expression. So I can now replace this log 2 in base 10 with this value. This is actually the substitution we are talking about, and I can replace my log 5 in base 10 with this value. So let's go ahead and do that substitution. So this is 3 times 0.3010 plus 0.6990. So if we will compute all of that, 3 times 0.3010, that will be 0.903 plus 0.6990 equal to 1.6020. That's my final answer. Okay, so I'm going to solve another example, example 2. Find the logarithm of 35 in base 10. Okay, if you want to solve this example, go ahead, pause the video and solve it. Then when you play it back, we'll continue together. Okay, so moving on, I'm going to look for two factors of 35 that when multiplied I'll have 35. And what are those numbers? That will be log 10 5 times 7. 5 times 7 is 35. Okay, and then next I will use my log outside to open the brackets. Have log 5 in base 10 plus log 7 in base 10, and to substitute those values and make this whole place look neat. Okay, so I'm working with these two values, 0.6990, 0.8451. Okay, I'll replace my log 5 in base 10 with that 0. It's also here, 0.6990, and my log 10, my log 7 in base 10, 0.8451. All right, and when we add these two values, we have 1.5441. That's our final answer. Okay, so let me solve the third example. I'm going to carefully wipe all this out. Okay, so the third example, number 3. Log 2 in base 10, 2 is raised to the power of y, equal to 1.8062. Find the value of y. Alright, so solution, we'll have log 2 in base 10 raised to the power of y equal 1.8062. We know that our power here, to make it easier for us, will be used to multiply this logarithm. So we have y times log 2 in base 10 equal to 1.8062. So we can substitute this value 0.3010 into this expression. That is y times 0.3010 equal to 1.8062. Making y subject formula, we will divide both sides by the coefficient of y, which is 0.3010, and this will cancel out since they are the same. So this expression, when we divide them, y will be equal to approximately 6. Actually, when you compute this in your calculator, it's 6.00 and some numbers, but if you approximate it, you have 6 as your final answer. Okay, let's solve. Let's take more examples. Trying to wipe this out. So example 4. We are asked to solve for x in x squared plus 1, all in brackets, minus 2 log x equal 1. Okay, this is actually log. Log should be here. And I said earlier that when we don't have the base explicitly written, we should know that it's 10, because this is a common logarithm, and here also is 10. But we can choose not to write it. It's still the same. Okay. So in this example, we'll simplify this expression. We can go ahead and open this bracket here. So we have log x squared. Okay, before we do that, there's something I just noticed. Let me erase this. Now, notice that in logarithm, this is minus, this is minus, and this is minus. And when we have two logarithm expression that are being subtracted, one is being subtracted from, like, to be more clear, this value is being subtracted from this value. The law says that when we have such scenario, log a minus log b is going to be turned to quotients. That will be log a all over b. So this is exactly what we are going to apply here. But first, we are going to take this 2 that appears outside this log, we'll take it back to the exponent of x. Alright, so that will be, I'm going to write this log x squared plus 1 minus, so this 2 is going back, so we have log x squared equal to 1. So we can now change this expression to the quotient form. So we have log x squared plus 1 all over x squared. Since the logs are the same, we just factored it out into this one expression and then take out the quotients of the logarithm values or logarithm expression, as the case may be. So we have this whole thing equal to 1. Okay, then we can do some manipulation. Log x squared plus 1 all over x squared. What do I want to do here? Notice that according to the rules in logarithm, one rule states that the logarithm of a number to its same base, when the number and that base are equal, you always have 1 as the answer, because 10 raised to the power of 1 is 10. So the logarithm of any number, no matter what that number is, 100, 1000, as far as the base is the same with the number, you always have 1. So we can replace this 1 here with log 10 base 10, because log 10 base 10 will still give us 1. The reason why we have to do this is because we want to cancel out the logs and their base. So these two will cancel out, and we are left with x squared plus 1 all over x squared equal to 10. So that's it. So these two expressions went out, and so that's a very important and handy rule that will help to make our solvings and our solution, the process of getting our solution, easy. Of course, I'm going to cross multiply, and I have 1 times this whole expression will still give me same x squared plus 1, and then x squared times 10 will give me 10x squared. Okay, so make a space. So I'll have x squared plus 1 equal to 10x squared. I can bring this x squared over to the side of the equation, and it becomes 1 equal to 10x squared. This is a plus, and when it crosses over, it becomes a minus, because a plus is in front of this x squared. So I have 10x squared minus x squared, and 10x squared minus x squared is 9x squared. If you have 10 apples and remove 1 apple, it becomes 1 apple. So the next thing, you want to find the value of x. So we make x subject formula, we divide both sides by 9. This cancels out, so we are left with x squared is equal to 1 over 9. And then we take the root of both sides. This becomes plus or minus here. So we have, they cancel out, so we have x is equal to plus or minus square root of 1 over 9. Okay, let me wipe this off. Going to wipe that off. And pick this up. Move this up here. Okay. So let me continue. So I have x is equal to plus or minus the root of 1 over 9. Okay, so x will be equal to plus or minus square root of 1 all over square root of 9. This is equal to, the square root of 1 is 1 and the square root of 9 is 3. So plus or minus. So x, our final answer for x is equal to plus or minus 1 over 3. So that's our final answer for that example. Okay, let me solve a very important example. Still under logarithm, and the example is this. Solve for a in 4 log roots of a in base 10 minus log 27a in base 10 equal to log base 10 a raised to the power of minus 2. Okay, so we'll begin. First, we know that root of a number is the same thing as that number raised to the power of half, because this square root and this raised to the power of 1. So this whole thing is equal to a raised to the power of 1 over 2, just like this 2 coming down here under the 1. Alright, okay, so this is log in base 10 a raised to the power of half minus log 27a in base 10 equal to log a raised to the power of minus 2 in base 10. So remember, there is a 4 here, but I'm going to take the 4 over to the exponent in a. So this will be times 4, because 4 is coming here. So I'm having 1 all over 2 times 4, and that is equal to 4 times 1, 4, 2 times 1, 2, that's equal to 2. So I have log, or to make it to save time and space, I'll just write my answer there, which is 2, because 4 times half is 2. Okay, and then if you can remember what we did in our previous example, when we have two logarithms being subtracted, one is being subtracted from the other, we'll change it to quotient. So we'll just factor out this log 10, factor it out, and then the first expression, which is a square, will be on top, and then the expression will be beneath. So 27a. Alright. And then I can now write this other side of the equation. That's log a raised to the power of minus 2 in base 10. Since they are all in base 10, log in base 10, they'll cancel out, and I'm left with a square all over 27a equal to a raised to the power of minus 2. And the inverse of a number in square is equal to what we have here, a raised to the power of minus 2. I picture this as, if you have something like this, a raised to the power of minus any number. This is the way I picture it. This minus in front of the b will be the division sign, and then the number a, and then the other one, and what should be on top is 1. So that's one way I use in understanding it. I don't know about you. So I'm going to transform, or I'm going to change this a raised to the power of minus 2 to I'm going to change it to 1 all over a square. So this minus in front of the 2 is acting like the division sign, then the 2 comes to the a and 1 on top. So we can cross multiply. Before we cross multiply, we know that a square is still the same thing as a times a, and 27a, so that this a and this a can cancel out, and we are now left with just only one a, not a square, just a all over 27 equal to 1 all over a square. So I can cross multiply. A squared times a will be a cube. 27 times 1 is 27. So in this case, we'll take the cube roots of both sides. So that, remember how I said earlier, when we have the cube roots or the square, as the case may be, of any number, because this is a cube, the reason why we have to take the cube root is because this 3 here will come under it, and it's going to be a raised to the power of 3 over 3, and that's a raised to the power of 1, which is still equal to a. If we have a square, the reason why we take square roots on the square of a number a is because this 2 will also go to the bottom. It becomes a 2 all over 2. So this 2 comes here, and that's equal to a raised to the power of 1 equal to a. Okay. And in other cases, when we have something like this, a square, we know that square here is 2, and what the exponent of a is 1 here, a raised to the power of 1 is a. So this 2 will come under the 1, and this is a raised to the power of 1 over 2. So that's some basic operations you need to know when solving that are very handy. So these will cancel out, we are left with a, and then you can go ahead and look for the cube roots or compute the cube roots of 27 in your calculator. So the cube roots of a number simply mean a number, let's call it a, that when you multiply it in 3 places, you have the number which you are being asked to compute or you are looking for. So what's that number that when you multiply it in 3 places, you have 27, and that number is 3, because that same number, which is 3, if you multiply it in 3 places, you have 27. So the cube root of 27 is 3. Just like the cube root of 8. Now in this case, we need a number, we call it x, that when you multiply it into 3 places, if you take out that number into 3 and you multiply them together, you have 8. So what's that number? 2, because 2 times 2 times 2 is 8. So that's what cube roots talk about. The same way square root of a number also mean what it mean as well. If I have 25, it simply means a number that when I multiply it with itself, that's in 2 places, that number will give me 25, and that's 5. So our final answer is a equal 3. Thanks for watching. That's all for now on this tutorial.